Okay, now and you're going to be told, you're going to give the model is S equals A plus BT. Okay, so you take your data. Or A plus BT equals S, and that's the order we're going to do it in. So our equations are going to be A plus 20T equals 35, and A plus 60T equals 29. Now I'll observe right there is a system of two equations and two unknowns that you can solve for A and B. And I wrote down T, my variable is B, T is the 20 and the 60, right? So 20 is T, so when I plug that in, I get 20B, right? And 60, T equals 60 gives me 60B. Okay, two equations that I can solve for A and B. But I've got three more equations. I've got plenty of data. So I will have also A plus 110B equals 17. A plus 160B equals 10. A plus 210B equals 2. Now I'll ask you to write down these equations. Now actually I don't think I ever gave you one where we had 5 of these. Okay, I think there were 3 or 4 in pretty much every problem that I put on the final. Well, this is of the form, didn't leave myself a lot of room, but it won't take a lot. A, X equals B. Same as this was of that form, but now your A matrix isn't as big. You just have 120, 160, 110. Didn't leave myself enough room, but I'll squeeze it in. Didn't leave myself much room there at all, so let's make it a little longer. Okay, 35, 29. I'm reading these because they're kind of small and the border's a little bit rough. 17, 10, 2. That might be hard to read, but these numbers are the same as the numbers you have here. So here's your A, here's your X, here's your B. Again, you can't solve these. You can solve any two of these equations for A and B. And you go ahead and take a couple of them. It just takes a minute or two to solve one pair of equations. You won't get the same values of A and B. Now you could solve every pair of equations and kind of average the values of A and B you get. You wouldn't get a bad model, but your best model is the one that uses the linear algebra and uses the matrices. And again, you end up solving this, and I give you this equation. And it's very easy to do A transpose times A. There isn't that much arithmetic involved. And this gives you a matrix equation that you can easily solve for A and B. Now I'm going to proceed to do that. So just got to figure out where to do it. Yeah, I can probably squeeze it in down here. Sorry for the quality of this board. I'll start using a different one. So A transpose A equals what? It equals the matrix 1, 1, 1, 1, 1, 20, 60, didn't leave myself enough room, 110, 160, 210. So I'm going to have to spread my ones out. 1, 1, 1, 1. And then that's multiplied by the matrix with 1, 1, 1, 1, 1, 20, 60, 110, 160, 210. Then what's that equal? Well, I multiply all these ones by all these ones, first row times first column, and I get 5. Now I multiply all these ones by this column, and I get the sum of these numbers. That's what, 80, 190, 350, 560. Then I multiply these numbers by this, and what do I get? Well, I get 560, a symmetric matrix. Because it's got to be symmetric. Whatever this number is, this thing is symmetric. Okay, then what I get here, I probably don't want to fumble on the actually, I've got the numbers I need, okay? You know, you got to get 20 squared, 60 squared, 110 squared, and so forth. That's exactly what I have in this column, isn't it? So it looks like that's going to add up to about 44, 69, 81, 85, 85,800. Check me on that. I think that might be right. Okay? Well, there's my matrix, so there's my A transpose A. Now, the matrix equation I get is that times the x vector, which is just AB, and that's equal to A transpose times B. Well, I don't need all that much more room, but I don't think I've got it. And of course, we have to multiply the A transpose times this B, which will take a little more arithmetic. So I'm going to kind of do that off camera, and I'll come back and I'll write out the equations you actually get. Now I'm going to probably erase this. That's about all I need to erase to write down these equations.